Hello again. In this video, we're going to begin talking about the material from section 3.5, where we find the derivatives of the 6 trig functions. So we're going to start with finding the derivative of sine and cosine. In order to find the derivative of sine and cosine, we're going to need to appeal to theorem 310, which tells us that the limit of sine of x over x as x approaches 0 is equal to 1. And I just want to show you that this is true graphically. So here's a graph of sine of x divided by x. Notice that it has a hole in it right here when x is equal to 0. But the limit as x approaches 0 from both sides, you can see from the graph that it's approaching 1. Okay, so the limit of this function as x approaches 0 is 1. Now the other limit that we're going to need is the limit of cosine of x minus 1 divided by x as x approaches 0, and that limit is equal to 0. And again, we can see this is true graphically. So this is a graph of that function, cosine of x minus 1 over x. And you can see as x is approaching 0, from both sides, the y value is approaching 0 as well. Okay, so the limit of this function, cosine of x minus 1 over x, as x approaches 0 is 0. Okay, so remember that because we're going to use that to find the derivative of sine and the derivative of cosine. Okay, so let's do that. Let's start off by finding the derivative of sine of x. Okay, we're going to use the limit definition of the derivative to find it. Okay, and so in this case, our f of x is just sine of x. Okay, so we need to find this limit. Okay, so we need f evaluated at x plus h. Okay, of course, when you evaluate this function at x plus h, you just get sine of x plus h minus f of x, which is just sine of x. Okay, and then we're going to take the limit of this as h goes to 0. Okay, now we're going to use a trig identity to break this up. If you may remember this identity from trig, sine of a plus b is the same as sine of a times the cosine of b plus the cosine of a times the sine of b. Okay, so let's apply that identity to this. And so we're going to get sine of x times the cosine of h plus the cosine of x times the sine of h, just using this identity, minus the sine of x. Okay, and all of that is over h, and then we're going to find the limit of that as h goes to 0. Okay, and now what we're going to do is we're going to group the first term and the last term next to each other. And then I'm going to write this term last. And then I'm going to factor out of the first two terms, I'm going to factor out a sine of x because it's in common with both. And that's going to leave you with cosine of h minus 1. And then I'm also going to break this up into two fractions. H is dividing all three of these terms. Okay, and so you can write it like this. H is dividing this first term. And, well, after I factor sine of x out, the top looks like this, and h divides that term, but h also divides this term. So you can write it like this. And essentially all you're doing is, this would be a common denominator, and if you have a common denominator, then you can combine the tops and then just put it over one denominator. Well, I'm just breaking it up into the two denominators where you have h in both denominators. Okay, and then we can break the limit up across addition. So you can actually find the limit of this first one and then add it to the limit of the second one. Okay, and then we can also break the limits up across multiplication. So this is multiplication, and so we can write this as the limit of sine of x times the limit of cosine of h minus 1 over h. And we can do the same thing here. This is the limit of cosine of x times the limit of sine of h over h. Okay, so that's just a property of limits. Okay, you can break limits up across multiplication as well as addition. Okay, and now this is where we're going to use that previous theorem, theorem 310. You remember from the previous theorem that this limit right here was equal to 0. Okay, and so you end up with the limit of sine of x as h goes to 0. That limit is actually sine of x, because as h is going to 0, this doesn't change. This is a fixed value. Think of x as a fixed value. As h goes to 0, x is not changing, only h is. And so as h is going to 0, this remains sine of x, no matter what h is. And so you end up with sine of x times 0 here, which of course is just 0. Okay, same thing over here. This limit's equal to cosine of x, because cosine of x remains fixed as h is heading towards 0. And so that's just cosine of x. And now this limit from theorem 310 again, if you remember, this limit's equal to 1. So times 1. Okay. And so we end up with cosine of x. Okay. And just remember that we're using theorem 310 to show that this limit is 0, and also to show this is equal to 1. This limit's equal to 1. Okay. So that's by theorem 310. Okay. So now we have the derivative. Derivative of sine of x happens to be cosine of x. Which is rather interesting. Okay. Okay. So then let's find the derivative of cosine of x. And you might think the derivative of cosine of x is equal to sine of x, and I think that's a good first guess, but it's not quite right. It's actually minus sine of x. So let's see that. Okay, so let's find the derivative of cosine of x. Okay, again, we have to use the limit definition of the derivative. In this case, f of x is cosine of x. Okay, and so using the limit definition of the derivative, we need to evaluate f at x plus h, and when we do that, we just get cosine of x plus h. Okay, minus cosine of x all over h. And then we're going to use a trig identity to break this up. And so you may remember that cosine of a plus b is the same as cosine of a times the cosine of b minus sine of a times sine of b. Okay, so let's apply that identity to this. Okay, and so that's going to give us cosine x cosine h minus sine x times sine h minus this cosine of x all over h. Okay. And again, we're going to take this first term and this last term, and we're going to put them next to each other. And then we're going to factor the cosine of x out of those two terms. Okay, so let's factor that cosine of x out. And that's going to leave us with cosine of h minus 1. And then I'm going to break this up again into two fractions. Since this h divides these two terms and this term, you can break it up like this. Okay, again, this is a common denominator. You can combine those two into this one denominator, which is h, and then just combine the tops by subtracting. Okay. And then since we're taking the limit of this, we can break this limit up across subtraction. So this limit is the same as the limit of this minus the limit of this. Okay, and then we're going to break it up across multiplication. Okay, so again, that's a property of limits. And then we can break it up across multiplication here as well. Okay, so we end up with that. Okay, and then we're going to appeal to theorem 310 again because we know what this limit is, right? This limit is actually equal to 0. This limit is just cosine of x, again, because h is heading towards 0, but cosine of x doesn't change as h is changing and heading towards 0. So that's simply cosine of x. Okay, and then over here, this is just sine of x. And then this limit, of course, is, again, by theorem 310, this limit's just equal to 1. Okay, so again, that's by theorem 310. Okay, so it looks like we get 0 minus sine of x, right, which is negative sine of x. Okay, so now we know the derivative of cosine of x. It's not sine of x, which is kind of odd. You might think it's sine of x, but it's actually the opposite of sine of x. It's the negative sine x, or the negative of sine of x. So the reason that happened was because of this trig identity. It has a minus sign in it. That's where that came from. That's what caused this to have a minus sign. Whereas in the derivative of sine of x, the identity we used in that proof, we had a plus sign here. Okay, so that's the reason we got a minus sign in this case, is just because of this minus sign here. Okay, so we've got derivative of sine is cosine, and we have the derivative of cosine is minus sine of x. Okay, so the next one we're going to look at is the derivative of tangent of x. Now the good news is we don't need to appeal to the limit definition of the derivative, because we can write tangent of x as sine of x over cosine of x. And since we already know the derivative of sine and cosine, we really don't need to go back to the limit definition of the derivative to find this derivative. We can just use the quotient rule to find this. Okay, and so the quotient rule, you may remember, says you take the low times the derivative of the high minus the high times the derivative of the low, and then you divide that by low times low. Okay, so let's take the low function and multiply it by the derivative of the high function. Okay, remembering that the derivative of sine of x is cosine of x. Okay, so low derivative of high minus high, the high function, and then the derivative of the low, which of course is minus sine of x. all divided by low times low. In other words, cosine times cosine. Okay, so let's clean this up a little bit. That's just cosine squared. This minus sign and this minus sign give you a plus sign, and that becomes sine squared. And of course, that's cosine squared. And then this is equal to 1, because sine squared x plus cosine squared x is equal to 1. That's another trig identity. And so you just end up with 1 over cosine squared, which you can write as 1 over cosine and then squared. Those are the same thing. And of course, we know what 1 over cosine is. That's just secant. Okay, so this is just secant squared. Okay, which we usually write like this. Okay, so we now know the derivative of tangent. Derivative of tangent is just secant squared. Okay, so then let's look at one more. Let's find the derivative of secant of x. Now again, we don't have to go back to the limit definition of the derivative to find this, because we can always write secant as 1 over cosine, and we already know the derivative of cosine. And we can just apply the quotient rule to find this derivative. Okay, so again, it's low times the derivative of the high. And of course, the derivative of the high is 0 because that's a constant. Okay, minus the high, which is 1, times the derivative of the low. And remember, the derivative of cosine is minus sine of x. Okay, all over low, low. So cosine times cosine. Okay, so low, derivative of high, minus high, derivative of the low over low times low. Okay, and of course you get 0 minus, actually plus, right? A minus times a minus is a plus. So you get 0 plus sine of x on the top, and that's all divided by cosine squared. Okay, and let's write this as sine of x over cosine x times 1 over cosine of x. Those are the same thing, right? And the reason I'm doing that is because sine of x over cosine of x is just tangent of x. And then this is just secant. 1 over cosine of x is secant of x. Okay, and so now we know the derivative of secant. Now usually we write it, and it doesn't matter what order you write this in, but we usually write it as secant x times tangent of x. Okay, so the derivative of secant of x is secant of x, but times tangent of x, which is kind of interesting. Okay, so we're making some progress. Now there's only two other trig functions that we need to find the derivative of. And I'm not going to actually work those out, but I am going to try to convince you because of the pattern that's evolving here. So the derivative of sine is cosine. But the derivative of cosine is minus sine. So one thing I want you to notice is this is a cofunction, right? That's why it's called cosine. When you take the derivative of a cofunction like cosine, notice that you have a minus sign in front of your derivative. So the derivative of sine is cosine. The derivative of cosine is sine, but with a negative sign in front of it because you're taking the derivative of a cofunction, namely cosine. Okay, let's see if this pattern continues to hold. When you take the derivative of tangent, you get secant squared. Okay? When you take the derivative of cotangent, which is a cofunction, you do have a minus sign in front. And you can see that this is cosecant squared, which is the cofunction of secant. Okay, so you don't get secant squared here. You get the cofunction of this, which is cosecant. And so that's why it's cosecant squared, but it has a minus sign in front of it because you're taking the derivative of a cofunction, right? Namely cotangent. Notice the same thing is happening up here. The derivative of sine is cosine. When you find the derivative of cosine, the sort of the opposite of cosine is sine, right, in terms of cofunctions. And so you know you're going to get a sine here, or a sine of x, but again, this is a cofunction, so there's a negative sign in front of that. Okay? Now let's see if this continues. We know the derivative of secant of x is secant of x times tangent of x. So what's the derivative of its cofunction, right, which is cosecant of x? Well, it's going to be the cofunction for secant, which is cosecant, and the cofunction for tangent, which is cotangent, but it's going to have a minus sign in front because this is a cofunction, right? Cosecant is the cofunction of secant. So I think you can see the pattern here. If I know the derivatives on the left-hand side, I can easily produce the ones on the right. Okay? Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.